Okay, this is still 2.6, except just going through a couple of examples here. On the first example, it says find the values of x and y. So think about the theorems and the postulate that we've covered here in chapter 2.6 so far. If I want to find the values of x and y, these two angles right here form a linear pair. So you could set up 3 times the quantity x plus 6 plus the quantity 5y plus 29 equals 180. You run into a small problem because you have two variables in one equation. You could also set 4x plus 7 plus 7y minus 11 equal to 180. What you would really have there is what's called a system of equations, something that you should have learned about last year in algebra. Two equations with two variables, which means you could use, if you remember, substitution, you could use elimination. You can even graph those, although I wouldn't recommend doing that. So that's something that you could do to find both the values of x and y, or you could use the vertical angles congruence theorem. This angle right here, represented by 3 times the quantity x plus 6, and this angle right here are vertical angles. Therefore, they should be congruent. So in my opinion, the easiest thing to set up is 3 times the quantity x plus 6 is equal to a quantity of 4x plus 7. Since those two angles are vertical angles. So notice we have an equation, and that equation only has one variable in it. It's pretty easy to solve that way. All right? So in order to solve this for x, we can distribute on the left side. 3x plus 18 is equal to 4x plus 7. I can get the variable to one side of the equation. I'm going to get the variable to the right side of the equation, even though it doesn't matter what side I get the variable to. I could have gotten the variable to the left. So now on the right, just x or 1x plus 7, subtract 7 from each side of the equation. 11 is equal to x, or x is equal to 11. The directions just say find the values of x and y. Maybe you plug that back in just to double check here. So 11 plus 6, if I plug it into this expression, is 17. And then 17 times 3, you get 51. On this angle, since these two angles should be congruent, 4 times 11, 44, plus 7, also 51. So this actually checks, even though I didn't write everything out there as far as checking. That's finding the value of x. We also need to find the value of y. So in order to find the value of y, you set up something pretty similar, except with these two vertical angles. So 5y plus 29 is equal to 7y minus 11. So I'm going to get the variable on one side using inverse operations. This is not algebraic reasoning. This is not 2.4. So I don't need to write the given equation, subtraction property of equality. Should at least be thinking about that, though. So then the equation becomes 29 is equal to 2y minus 11. Going to add 11 to each side of the equation. So then 40 is equal to 2y. And then divide each side by 2. To solve it for y. Y is equal to 20. Again, that's all it asks to do, find the values of x and y, but you could substitute that back into both of the expressions with y just to double check. 7 times y, so 7 times 20 is 140, and then minus 11, 129. 5 times 20, is 100 plus 29 is 129. So that checks for y as well. Okay. And then on the second example, now we want to use what's set up for us already in this 2-column proof to fill out either reasons or statements. It might be helpful if you're following along, like if you had your list of definitions, postulates, properties, and then now theorems as well. So look at what's given. Angle 1 and angle 2 are supplementary. That means they have to add to 180 degrees. What might help some people is like assigning specific measures in here. Maybe if you use a protractor, I just kind of estimate angle 1, maybe about 135. Then that makes angle 2 45 degrees. 135 plus 45 would be 180. And then angles 1 and angles 3 are supplementary. So if angle 1 is 135, then angle 3 would be 45 degrees. And then you want to prove angle 2 is congruent to angle 3. Okay. So the first statement is what's given. First reason is given. Really, the first reason should always be given. Then second statement is the measure of angle 1 plus a measure of angle 2 is equal to 180. The measure of angle 1 plus a measure of angle 3 is equal to 180. You have to look back at the first statement as well. Angles 1 and angles 2 are supplementary, so are angles 1 and angle 3. So the next reason for statement number 2, again, maybe pause, think about it on your own, but it should be the definition of supplementary angles. Two angles are supplementary, then their sum is 180 degrees. So the definition of supplementary, or definition of supplementary angles. I'm going to abbreviate some things, especially since I'm running out of room, using the symbol for angles. And then to figure out the next statement, the reason is given. You definitely should be using that. Transitive property. So if the measure of angle 1 plus the measure of angle 2 equals 180, measure of angle 1 plus the measure of angle 3 is equal to 180, maybe you'll look at the next statement as well to kind of figure out something that you might use as far as a statement. But by the transitive property, since both of these items are equal to the same thing, they're equal to each other. Measure of angle 1 plus a measure of angle 2 is equal to, now instead of 180, the measure of angle 1 plus a measure of angle 3. Because if you notice the next statement, you have the measure of angle 2 is equal to the measure of angle 3. And then what's missing on each side of the equation is the measure of angle 1. Because you can get rid of that by subtracting it from each side of the equation. So reason number 4 should be the subtraction property of equality. And then, yes, you could look at the next reason, but the last statement really should always be what you're trying to prove. Just to double check, the statement previous to that is measure of angle 2 is equal to the measure of angle 3, and what we wanted to prove is that angle 2 is congruent to angle 3. If the measures are equal, then the angles are congruent. That's the definition of congruent angles. Angle 2 is congruent to angle 3. And then we're done.